All right, I'm going to show you guys law of sines. And first off, to kind of give you a little preview, when you guys were taking geometry, IM2, you guys did proving triangles congruent. So you'd have two triangles and you had to show that they were congruent. But to show triangles congruent, they had to prove at least three things in each one. You could do side, side, side if all three sides equal all three sides. Side, angle, side, angle, side, angle, 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 side. This was not one. ASS did not work. The reason why they said it doesn't work because it only sometimes works. Wasn't for sure. If these were true in one, they are automatically true for every single part of the triangle. So that's why these are so important. Now, why am I telling you this? Well, if we know an angle, side, angle, that would be like this picture right here. I know an angle, a side, and an angle back to back to back. Then I can solve it using law of sines. If I know an angle, angle, side, here's one like that, an angle, and a side, then I can do law of sines. So these are where I'm going to show you law of sines. So if it looks like this, we'll eventually get to these two. If we have the side, 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 and we have the side, angle, side, then we cannot do law of sines. It won't work for us, but we can do law of cosines. Okay? Now, when we get this is going to be a day called the ambiguous case. If we're given this information, it will work sometimes. It may not work at all. You may actually have two solutions that work for it. So a lot can happen. That's why it's so ambiguous. We don't know if there's 0, 1, or 2 solutions, okay? So we'll get to that later. Let me erase this up right here, but we're going to work with law of sines. Now, instead of getting it all complicated, you're like, man, I don't know what all that ASS and all that stuff is. Here's what you're looking for. So if you look at this picture, if you see an angle and the side across from it, see how the 18's across from the 40? If you have, they call it an angle side pair. If you have that, then you can do law of sines. All right? So I look at that and go, hey, I got that, I can do law of sines. When you look at this one, you're like, oh, I got this side, I don't have this angle. But if we know two angles in a triangle, we automatically know the third. So we actually can do this one by law of sines. We have to find the angle real quickly, all right? So here's how law of sines. It's a pretty simple formula. It's A over sine of A equals B over sine of B, which also equals C over sine of C. So not all of them at the same time. You just pick two of those. You can do these two or those two. So you can just do it. It's just a pretty easy little ratio, okay? You can also put the angle on top. Whoops, wow, I don't know where that came from. All right, you could also put the angle on top. It doesn't matter. So either put the angle on top or the side. Here's what I do. Whatever I'm looking for, I put it in the top left, so I don't really care, and that way it's easy to solve for. It makes my life easier, okay? So let's go ahead and do these real quick. Since I know those two, I can use those two as one pair that I know, and we can find another pair. So the only other one I could do with this information right now is I can find A, because I know the angle across from it, I can find this side. I know nothing about C. I don't know its angle or side, so right now I can't do anything with C. But I could find the angle first, and then I'm ready to go for C, okay? So if I were seeing this, if I have two angles in a triangle, I can clearly find the third angle. So we add 51 and 40, that's 91. How much is left? 89 degrees. All right, so we're gonna have to find it eventually. Might as well find it right now. All right, so now I can find either side first, whichever I want to. So let's go ahead and find A. Okay, so here's how you do it. Since I'm looking for side A, I need side A and side C. I put A over sine of the angle that's across from A. So A is across of 51. So A over sine of 51. And then I have to use one I know because I have to have only one known to solve a problem, so I better know both these values. Well, I do if I use B. So it's 18 over sine of 40. All right? And then so now I can multiply both sides by sine of 51. of 18 times sine of 51 over sine of 40. And I punch that in my calculator. Make sure maybe use your fraction button to help out. I've already done it. Let me see. The solution for A was 21.8. So typically we'll have you round the sides. The nearest tenth is good. Depends on how accurate we want to be the angles. We can do to the nearest degree, to the nearest tenth, to the nearest 10 minutes. You know, probably we'll just do the nearest tenth for what we're doing. You know, especially with the distance learning, it'll be a lot easier than trying to teach all that calculator stuff again. So now I got this side. The biggest mistake people make here is they think they can do Pythagorean theorem. This is not a right triangle. Pythagorean theorem does not have any, chance of working here. So do not even bother that. It only works in right triangles. Okay, it's great, but we don't have a right triangle here. So to find the third side, I have to do law of sines again. So the side across angle C is called side C. So C over sine of 89. I put the side over the sine of the angle across from him. And again, I can use the 18 and 40. Now, technically, I could use, because I now have B, or the A, I could do 21.8 over sine of 51, but I'm using a rounded answer. Remember, I rounded this 21.8, so then that would make C off a little bit, so your actually goes down a lot. So I recommend you just always use the angle side pair that's given you, and you don't have to worry about accuracy. So if you solve for C, all right, you punch in your calculator. I've already done it, and we get 28.0. All right, I'm gonna double check that. I wrote the right number down. Yep. So, and that's how you solve a triangle. So with law of sines, if you have the right information, remember you're looking for an angle side pair, then you can continue with law of sines, and then you can find the remaining information. Now, SOHCAHTOA does not work. You can't go, oh, sine of 40, there's no hypotenuse because there's no right triangle, so don't even use SOHCAHTOA. All right, but law of sines can work on right triangles. So we could go back and do those homework over in chapter 4s and 5s and say, hey, I want to do law of sines instead of SOHCAHTOA. I don't recommend it, but it works. It's, it's pretty much the same. I mean, it's, maybe 5 seconds longer. But yeah, you could do law of sines and cosines on right triangles too. But to me, SOHCAHTOA is faster. All right, so let's go ahead and I'll be erasing this in just a second. In my notes, I had also area done for you. You'll see a K in my notes. I will do a section on area. We'll do a different notes for the area. Okay, so I'll come back to that. All right, so let's go ahead and do this guy right here. Now I just changed the letters around X, Y, and Z. So we're missing angle X. That's missing. We're missing side Y and side Z. Okay, in that picture. So those are all ones that are missing. So let me get this out of the way. So I have a side, but I don't have the angle across, but I can find it. So if I add those two together, 37 and 61, we got 98. So there's 82 degrees left. So this one's 82. Sorry, I kind of scrunched it over there, but 82 degrees, and you can fill it in. I have that written on the notes also. So now I can find either Z or Y. Doesn't matter which one you want to do. Let's go ahead and find Y. So Y, here's side Y. Side Y is always across from angle Y. Y over the sine of the angle that's across from it, sine of 61. And you have to use something you know. The only one I know is the axis. So 44 over sine of 82. All right. So now I multiply by sine of 61. Punch that in my calculator, do all that work. And what do we find? Y, and I have 38.9. I'll put it up here in the picture. And that's how long that side is. Okay? All right, and then Z, Side Z is over here. It's across angle Z, which is 37. So sine of 37. Don't forget it's law of sines. So you're taking sines. Equals. And again, I can use the 44 sine of 82. All right. I could use the 38.9 sine of 61. You maybe try it just to see, and you'll get a afterwards, and then see how close it is. It'll be off by a little bit because you're using a rounded answer. It's not going to give you the most accurate. All right, multiply by sine of 37. All I'm doing is multiplying both sides by sine of 37, just like I did all the rest of them. Punch that in my calculator. I've done it already. It turns out to be 26.7. So it's really not too difficult of a formula. It's a really useful one. I've gone back and messed with SAT questions, and when I get these calculators, you could do law of sines. A lot of people don't know it. You have a little advantage over a lot of the other students who are unaware of the test. So, but yes, law of sines helps you solve triangles, which is kind of cool. All right. And I'll eventually in the next video show you guys, well, in another video, ambiguous case, and show you the weird ones.